So welcome. Nice to see that it actually is still people left. Like the last session could be like 7 people. We can move them to stage. What's going to happen is that I'm just going to very quickly explain what's the rhythm of this session, and it's going to be 3 small presentation from Ole, Carole, and me, just to kind of create a framework. And after that, we go into a discussion of different subjects which are made. And between us, if they were not listening, in the first note I make for them, I said, and that's freestyle. And 2 so renowned scientists in each that field were writing back, freestyle? And I think that's a typical chef thing, like, okay, we take what's there and then we go for it. And then we start working on subjects that we think are important for this session. So we go back and forth. And we will hopefully end with a little video and something about our surroundings. So that on the side. For me, I heard some of the sessions up here on many different subjects, how humans interact, how we smell and not, and how the space is important, and is food the same if we eat it in a clinical white room without hearing and out, with the eyes covered and all this kind of stuff. And I just realized that, and that's what we talked about also, it's where did it start, where should it start? And for me as a chef, taste and being creative and sociality, link between human. These are the 3 ingredients I need to work as a chef. And to understand how taste and creativity works, you need a brain. And so to explain how the brain works in a very understandable way, I'm lucky to have Ole to help me explain that, and us, which is going to be one of the platforms we're going to use today for later. So Ole, if you please help us in that matter.
Because I like to see you folks. And I like us first to do a little experiment. So could you please look at your neighbor and wonder and notice the neighbor how big a head the person has. Do you realize you all have very big heads? I can see it from up here. You actually have maybe 10 times as much as you really deserve biologically. So you have very big heads, and then take a closer look at each other. You have fairly small noses. Notice that? And you also have a very flat face. Look at your neighbor. Look at his very flat face. Isn't that amazing? Now, you have the head you deserve, as I say, or maybe you actually have a head that is bigger than you deserve, because there's something in here. It's a brain that constitutes 2% of your body weight. And the way the brain is, and the way your head is, the way it's shaped, that has to do with what you eat and how you eat. And when we're going to unfold our session, we start with the brain, we start with the sensory perception. There's a processing happening in the brain. And we're going to talk a lot about taste, and taste proper in the sense that it is a signal that comes from the tongue. So let me ask you to do the last experiment. Show your tongue to your neighbor, like this. And you can do a little counting if you had some color to put on the tongue, and you will notice you have a lot of taste buds. So this is where the taste sensation proper, that's actually where it starts. But this whole system, the way why the taste buds and the brain talking to each other while interaction between human beings, that's what we're going to talk about. So the question is, how did it come to that? So we have to go back in time, and Gordon Shepherd already yesterday talked a little bit about it. We have to go back 1.9 million years in time. And this is what anthropologists now think is about the time where we started using fire to cook. And it's this wonderful book by Richard Wrangham. He says, man is a cook, man is a chef. And beware of the fact that we, Homo sapiens, we're the only species that heat prepare our food. And as you know, when you heat prepare the food, and I'll tell you about that, it releases a lot of flavors and a lot of taste compounds, and it's often happening around the fireplace. So that's why we have a fireplace on the stage here. So 1.9 million years ago, our ancestors started using fire. And what happened during that process, and I'll tell you what happened to the food, but the most important aspect of that it gave our ancestors time. Because you have to realize, before you started using fire, you may have to forage 8-9 hours a day to find the food, and you would have to spend just as much time chewing. And maybe while I'm speaking, you can think about how long time are you going to chew today. And if you want to make a comparison, you go to the zoo and look at some of the other higher primates, and you will see, of course, they fed the food. They don't have to forage the food, but they chew about 8 hours a day. So that's the conditions of life 1.9 million years ago. Now you've got fire, and certainly fire does something to the food that actually eventually releases time. And if there's something that is very necessary for building interactions between people, setting up society, civilization, developing language, communicating, you need time. So the statement in Wrangham's picture here is that the commensality around the fire that led to families, I guess the first time, maybe you wouldn't even call them a family, it was just sort of lovers. I mean, they met together and they shared the food, and eventually it gave the rise to social structures around the common meal. So you should imagine our ancestors, they maybe tossed the meat into the fire, or the vegetables, or the tubers, whatever they could find, and it changed the food. And later in time, of course, and this is way up in time in Neolithicum, you started having pots. And what I think is going to be essential for discussion later, that's what's happening in this pot. In particular, what is in the bottom of the pot when we put all these ingredients in the pot, and there's something, the most tasty stuff, that's on the bottom of the pot, and the sharing around the pot, sticking into the pot and eating it, that's what is, I would claim, is the origin of commensality when it comes to food. Then I'm going to be a little technical, because the question is, what is happening to the food? And I'll come back to the chewing while this. So that a lot of things happening when you heat prepare the food. You're changing the composition of the food. You're changing the carbohydrates. You're changing the proteins, and you release flavor compounds. There's something oozing out of the pot. When you're tasting what's in the bottom of the pot, and say it's a piece of meat, it's changing taste. The nutrients getting more easy accessible, they're more easy bioabsorbable, and that leads to a very important thing, and which also Gordon Shepherd mentioned yesterday, that is it releases energy. You get much more energy than you would get on a raw diet. And this energy is absolutely crucial. It's one of the two crucial things in order to build a big brain. You may not realize, but your big brains, it's spending more than 30% of your energy, even if you sleep. It's a very costly system. And that needs energy, but it also, as we come back to in a few minutes, it also needs a particular kind of foodstuff, and that is certain kind of fats. There are other things that's also happening when you cook the food. But I'll just make the last point in terms of evolution, that is what this heat treatment, it leads to softer food. And a little later, we're going to talk about softness in food, and Thorsten is going to take us into space, and I think it's going to be an issue how soft food you would really enjoy. But certainly get soft food, the advent of fire, and you don't have to chew as long. So I don't know how long you're chewing, but you certainly, I think probably none of you are chewing 8 or 9 hours a day. So this is what another anthropologist, Daniel Lieberman, who wrote a wonderful book about the evolution of the human head, and also later the evolution of the human body and fact that we are fast runners and we can run for a long time compared to other organisms. But the fact that we don't chew as much has changed the shape of our heads. So when you notice your very flat heads, it's due to the fact that the jaw has retracted over time. You need less force to chew the food, and you sort of get this very flat face. And I'm sure a chimpanzee would say we look terrible and very different for them. And we would say, well, look at this face with a very big jaw and big mouth and very strong jaws. So in that sense, you can sort of elaborate on Savarang's statement that you are what you eat. Lieberman says you are how you eat. So the fact that we don't chew as much. So a little bit about the molecules and taste. And now I'm going to talk about taste proper, and I'll put that in the context of criminality. So what does molecules taste of? And when we ask ourselves, what do we eat? Well, we eat things that are either alive or have been alive, and they're constituted of 4 different components that are very important for taste. We have proteins, we have carbohydrates, we have fats, and then we also have nucleic acids. And it probably a surprise to you that none of these molecules have any taste. We don't taste of anything. We don't have taste receptors that can identify them. So this is where cooking come in, because once you start working on these molecules, they break down and they turn into smaller pieces. And some of these smaller pieces is actually something our sensory apparatus can detect. So let me just show an example of 2 that will be very important for one of the tastes we're going to talk about, the umami. And I'm not supposed to apologize for molecules on the screen because I'm a scientist, so you're allowed to do that. You don't have to remember the names. The only thing is you need to know the small entities you can taste. And small entities of proteins they call amino acids or peptides, and those you can taste. And there's one I'll come back to now in a second, one that really is in the bottom of the pot, that is glutamic acids, which is a very important part of proteins. And the source of glutamic acids called glutamates, that is what stimulate the 5th flavor, which is related to delicious food. And I would claim that particular taste is the taste which, if I should choose one taste, a taste proper, that I would characterize the commensality around a meal. That would be this 5th flavor, which is we call umami, and which is due to glutamate. But there's more to it, and that is that there's actually an underlying molecular cooperation here, sort of molecular commensality. The other set of components here are breakdown products of nucleic acids, something you'll never read on the back side of the ingredient list of a food compound because they're not considered to be important for nutrition, but they're very important for taste. And some of these breakdown products they call nucleotides, and there are 3 different kinds here, inosinate, guanylate, and adenylate. You'll find them in respectively fish and meat, mushrooms, shellfish, the adenylate, scallops, for instance, or tomatoes. They break down products of nucleic acids. And the wonderful thing about these 2 different sets of molecules, that is when you get them together, there's something wonderful happening. There's a sort of a tango on your taste buds. You have the glutamate, you have to decide which one is glutamate. I'm not going to tell you, but there's glutamate that is sort of performing a tango together with one of these nucleotides. And the enhancement of the taste, which got the name umami about 100 years ago, that is strongly enhanced by these 2 different components. And this is part of the reason why we talk about deliciousness of food when it comes to the chemical composition of food. And umami is actually a construct of umai and mi, and umai means delicious in Japanese. So this is something you will get when you heat treat food. And this pairing is something, maybe Thorsten and I will discuss a little later how you use this pairing, but you know it in all cuisines. In the Japanese cuisine is a combination of what seeps out of seaweeds or a particular kind of very processed fish product called katsubushi. So you get glutamate from one and inosinate from another, and when they get to the taste receptor, and maybe a little later I could describe how the taste receptor works, it's this wonderful dance, you get this enhancement of taste, and this is what I could call molecular commensality. And this kind of pairing, which is very different from the kind of pairing many people within molecular gastronomy earlier talked about, this is a pairing that is based on a scientific principle. It's something where we know for sure it's working on a molecular receptor level. The pairing you know in all sorts of cuisines. If you go to Italy, the pairing would be tomatoes on one side and maybe meat, minced meat on the other side in the sauce bolognese. You go to Britain, you would have a combination of egg and bacon. And for sort of a Western soup or even Chinese soup, you will have a combination of vegetables and meat. And we have lots of vegetables here and lots of meat, so we could actually cook a very nice soup. So the question is, and this is what we're going to lead over to the next presenter, that is, and that's an issue we discuss all the time, and we sort of really, and Paul Rosen also this morning sort of indicate to us, we have this issue, what are we supposed to eat and what can we eat and what should we worry about? And I'll pose the question sort of a little different here. What should we eat in terms of what we are destined to eat from the point of view of evolution? And that's not what our parents ate or what they ate in the Middle Ages or what they ate in the Stone Age. You have to go way back. What are our genes telling us to eat? And then we'll see that like the ancestors who gave us these genes, and you know the genes are not changing very quickly. It's the expressions of the genes that are changing, and the expression of the genes is very sensitive to environment. And one of the most important things of the environment, that is our food. So what did these people eat? Well, you can still indicate that they probably ate something different from this guy over there. And it's well known now that our species, we sort of evolved not on the savanna, we evolved in coastal areas close to oceans and lakes. And what do we find there? We find seafood. And the seafood is actually very essential for bringing the other component in you need in order to have a functional brain, a big functional brain. There was energy at one point, but of course you also need the material, this particular stuff your brain is built of. And the brain is about 70-80% fat. It's the most fatty organ you got. And more of half of that are very special fatty acids called polyunsaturated fatty acids that is in a very particular combination of what we call omega-6 and omega-3, almost equal amount of the two. So if you ask, where does this fat come from? Well, maybe you think it comes from the fish. Well, in principle, you can get it from the fish, but the fish actually get it from further down the food chain. It comes from the algae. It's the algae, the macroalgae, the seaweeds, and the microalgae, that is actually what is producing this. And the wonderful thing about seafood is it is also very rich in the compounds that elicit umami. And so the flavor or taste of the sea where we came from, one of the most important taste of that is actually umami. So just to finish off with what I mentioned, I was sort of a little brutal to say you have very big heads. I'll just show you here the comparison with other organisms. And this is relationship between the weight of the brain and the weight of the body. And it has what scientists call a logarithmic dependence. And it falls off like this. And you see small animals have big brains compared to the body sizes, and big animals have small brains. And most fall on this curve. But you see there are two outliers. And one is Homo sapiens, and the other one is the dolphin. And both us and the dolphin, we have very big brains, typically 10 times as much as we deserve. So if you should have the brain you deserve, it should be about 1/4 liters of fatty cream. And here's the guy who evolved on the savanna, and this is the brain of the rhinoceros. Then it really comes back to the fire, sharing food around the fire, developing nutrients in the pot around the fire, developing taste buds that guide us to this particular kind of food. And the taste buds, that part of the taste buds that elicit umami, they guide us to proteins. So that's a signal for survival, just like sweet is a signal for calories, which is also very good for survival. And it may be no surprise to you that it's this sort of imprint on us to look out for sweetness and umami is something that is also carried out both during pregnancy. There's in the fluids in the uterus, it's very high in glutamate, and in mother's milk, the first meal we have, I don't know if you want to call this a communion meal, but it's actually a meal we have mother together with the child. And if you ask what the two most characteristic taste compounds of the mother's milk, it's umami from glutamate and it's sweet from lactose. And then it's also very fat. And so the child after birth also is imprinted with this desire to look out for these particular taste compounds. Now, yesterday, Mark Schatzker pointed out this critical situation we are in where flavor and nutrition has sort of become separate. And our desires to look for certain flavors no longer necessarily guide us to the food that is the most healthy for us. And I'll just throw one thing out here, which has less to do with commensality and less to do with food, but also with health. And that is that there's a very strong signal in the development of non-communicable human diseases. Then there's the growth in neural diseases. And in Europe, last time it was calculated, we spend more than 400 billion euros a year to treat neural-related diseases. And so we are going to see a change in burden of ill health, just as we saw in the beginning of the 20th century towards heart and coronary diseases. We now see a move towards mental diseases. And there's no doubt that this is due to the fact that we eat too little from this sort of chamber of food where we were actually brought up around the coast. And so this is part of us. This is origin. This is where we came from. This is the flavors and taste that we are imprinted with to seek out. And the most powerful way to get the stuff out is in the pot around the fire. So